Hey everyone, in this video I'm going to go over everything there is to know about users, groups, and permissions. Now on Linux, Linux is designed to allow more than one user to have access to the system at any given time. And in order to facilitate this multi-user design, we need to ensure that there's a way to protect users from each other. Now on Linux, each user has limited permissions when it comes to performing certain tasks and accessing certain files. We have a concept of groups as well. And now what groups are really just a collection of users. A user belongs to a default group when they get created, and it can also be a member of any other group on that server. They're primarily only used for the purpose of making it easy to give people access to files and folders and to restrict access to certain files and folders. That way, instead of changing the permissions of each individual user, you can just change the permissions of a group, thus saving you time. And just to give you an example of how that would work, let's say we have a server and this server is located at a hospital. And let's say that we have doctors, nurses, and janitors all at the hospital who have an account on the server. Now, why does the janitor have access to the server? I don't know. Actually, why does the doctors or the nurses have access to the servers? That's not even realistic either. You know, the doctors and nurses would have access to the applications that may run on the server, but usually only the server admins would have actual access to the servers. But just kind of roll with this analogy. Now, let's say that there's a folder on this server called patient info, and this folder obviously contains all the info about all the patients that have come into the hospital, and they carry, I guess, confidential patient information. Now, you don't want the janitors to have access to this information because they don't need to know that stuff, but the doctors and nurses do. Now, we could go into each individual user's account, and that's for all the janitors, all the nurses, and all the doctors, and make sure that each user who is a doctor or a nurse gets access to that directory. And we can then go into each individual user's account for the janitors and make sure that they don't have access to that directory. And that'll work just fine. The only problem is, what if you have 100 janitors, 1,000 doctors, and 5,000 nurses? Are you going to tweak all those accounts? Are you going to modify all the permissions for all those accounts? No. So what we can do instead is we can create 3 groups, one for doctors, one for nurses, and one for janitors, and we can make sure that we modify the permissions of that patient info directory to give access to that directory to the doctors and nurses, but make sure that the janitors don't have access to that directory. So that would ultimately end up saving you a lot of time because you only have to modify permissions for 3 different groups instead of hundreds or thousands of individual user accounts. All right, so that's kind of all the theory I wanted to go over. We'll discuss permissions a little bit later in the video. For now, I want to go over how to, look at what users and what groups are configured on a server, as well as how to add users and add groups, as well as delete users and groups. All right, so let's head on over to the command line and take a look at that. So to view all the users that are configured on Ubuntu, all you have to do is just look at a file that's located in /etc called passwd. And if you remember to open up a file in Linux, you could just do cat, and that'll just print out all the contents. We actually will need to do sudo. So sudo /etc/passwd. And no, that's not a typo. So what this is going to do is this is going to show us all the users configured on this server. All right, and there's a few default users that are configured, but if we scroll all the way to the bottom, right here, these are the 2 users that I've configured. This is the user I configured during installation, and I recently added a user called user1. So just to reiterate, to view all the users configured on a server, you just look at the /etc/passwd file. Now, let's take a look at this file a little more in detail. For each user, we have the username here, and you see we've got this specific path right here. And what this is the home directory of this user. Each user, when they get created, get assigned a certain home directory, and by default, that home directory is always going to be /home/ the name of the user. So for the user Sanjeev, it's /home/ Sanjeev. And if we take a look at user 1, the home directory is at /home/ user 1. Now, there are some groups that are already configured on this server. To view all the groups on a server, there's a couple ways to do that. Just like the passwd file for users, there's a specific file called group that'll show you all the groups configured. And all we have to do is just do the same thing. We can just cat that file, and that's also in the /etc directory, so /etc/group. And when we do that, ignore the groups all at the top. These are just ones that are configured by the system. We want to go to the bottom again and see these two specific groups. And you can see here that, oh, is that, are these the names of the users? Not exactly. Every time we configure a user, we also configure a group with the same exact name. So these are the two groups that got created when I created the user. So we have a group Sanjeev and we have a group user1. So those are the only two groups that we want to focus on for now. The rest are just defaults. Another way to print out all the groups configured is to type in get ent and then group. And it prints out the same exact thing. It just prints out the file. It's just a little quicker way to do it. But you can also just look at the /etc/group file. Now, if you want to find out what groups that a specific user are a part of, all we have to do is just type in the word groups. And you can see by default, the user Sanjeev, which is what I'm logged in as, is part of the group Sanjeev. There's a few extra ones that it got added to by default. The only other one I would pay attention to is sudo, and this gives me sudo access. If we switch to the user1, we can see here it's going to be a little different when I check out the groups that it's associated with. So here it's just user1 by default. So anytime you configure a new user, we'll have the group that's the same name, and that'll be the only group he's a part of. I had to manually go in and give him sudo access, and I showed you guys how to do that in the video where I explained what sudo is, so I'm not going to do that again, but I did want to show you just how to verify what groups that you're a part of. Alright, so now that we've seen how to verify all the users and groups on a system, let's go over how to add a user. Okay, now to add a user, there's a command add user, and if you want to know how to use this command, obviously just do the -- help, and that's going to give you a quick example of how to use the command. But it's a pretty easy command. All we have to do is add user and then the name of the user that we want to add. So let's say we want to create a user called user2. We'll need sudo, of course, and it's going to ask for my password, and that's the password for user1. Now, after you enter the password for sudo, it's now entering, or it's prompting you to enter the password for user2. So this is where we're actually creating the password for this newly created user. So just go ahead and enter in whatever password you like. You're going to have to retype it as well. And you can provide other details like names. We can call this guy Carl Schmidt. Room number, who cares, who cares, who cares, who cares. Is this information correct? Yes. All right, so we've created a new user. Let's verify if he truly got created. So remember to do that, let's just check out the /etc/passwd file. And you can see down here, we have our new user. You can see his name is stored in there as well as his home directory. which remember, it's always going to be /home/ the name of the user. And this can obviously be tweaked if you want to change what home directory is for a specific user, but don't worry about that for now. Okay, so now I've shown you how to add a new user. I do want to explain one thing. The /etc/passwd file that we're looking at right now, we can modify this file to change any behavior. All right, so if I go into this file and change the home directory, this line right here, and make it /home/ downloads or something, that'll actually change the home directory of the user. So you have to be very careful when you're tweaking the passwd file, because you could end up corrupting a user and making it so that they can't either log in or just completely break their access. So if you actually want to do this by modifying the text file, instead of just doing vi or nano of /etc/passwd, we have a special command called vipw. So do sudo vipw. And when you run this for the first time, it's going to ask you for what you want the default text editor to be. So you have the option of nano or vi. I always like vi, so I'm just going to select 2. And now here, I can now edit this file to tweak or modify any of the users configured in this group. And by doing this method through the vipw command, it's an extra protection mechanism for you, just in case if you put in a typo or something like that. It'll run some checks in the back end for you just to make sure that you didn't mess up the configuration. So anytime you make any changes to this file, you want to do it using vipw, just in case you make any mistakes or anything like that. Because just going into sudo vi/etc/passwd, that's risky, because there's no extra checks the system is going to make. If you misspell something or if you delete a line and then save the configuration, you could potentially lock yourself out of your own machine. All right. So I'm going to just close this out without making any changes. So I've showed you how to add a user. Let's talk about how to add a group. To add a group, we have a command called group add, and then all you have to do is just append the name of the group that you want to create. So we just do sudo, then group add, and the name of the group. Let's say doctors. And let's create another group called nurses, and another one called janitors. Now remember, how do we verify all the groups that are configured on a system? All we have to do is just take a look at the /etc/group file. And you can see at the bottom, we have doctors, nurses, and janitors, our newly created groups. And just like with the passwd file for users, the /etc/group file can be manually changed as well. So we can do sudo vi/etc/group, and we can make whatever changes we want. But as just like with the passwd file, instead of just manually doing this with your text editor, there's actually a special command that we can run just like vipw that'll do or perform extra checks to make sure that we didn't accidentally corrupt the file or make any bad changes to the file. And that command is vigr. So you just do sudo vigr, and that's going to open this file in a text editor, and the system will run checks as we make any saves or changes to that file. All right. I'm not going to bother going into it. It works the same way as vipw. Actually, I'll go ahead and just show you real quick. See, it does the same thing. So now we're in here and we can make any changes. I can add a user, delete a user. One other thing to point out is, let me quickly go over this. You can see here, let me find the sudo. Give me one sec. Let me see if I can get you there. You see the sudo group? Basically, the way this document works is you have the name of the group, And then you have a list of every single user associated with that group. So you can see here for the sudo group, the user Sanjeev and the user 1 are all part of this group. So if we deleted user 1 from this line right here, he would no longer have sudo access. So for all of our newly created groups like doctors and nurses, if we went in and under doctors put in, like my name, right, it would now associate the user Sanjeev with the doctors group. So I would now be part of the doctors group. So that's basically how this this file works. It's pretty simple, but I wouldn't recommend tweaking it if you're just starting to get used to Linux, and if you're just trying to familiarize yourself with the basics. All right, so let me exit out of this. Okay, so now we've learned how to add users and add groups. I wanted to go over one extra thing when it comes to groups. A user can be part of multiple groups, right? So I can technically be in the group doctors as well as in the group nurses. I can even be part of the group janitors. I can be part of as many groups as I want, but there's only one primary group that I'm associated with. All the other groups that I'm associated with are considered secondary groups. The user's login process and file and folders that the user creates will be assigned to the primary group. And by default, the primary group is going to be the group named after the user itself. So I'm user 1, and if we look at groups, we can see all the groups I'm a part of. So I'm part of user 1 and sudo. Now I know that when I create a user, the primary group that I'm going to be associated with by default is the one that's the same as my username, which is user 1. But if you want to verify what your primary group is, you just run the command id-gn, and that's going to tell you what your primary group is. And your primary group, if you create a file, the permissions and the group and user ownership of that file are going to be based off of your primary group. So if we we're in our home directory, we can just change to cd that. So this is our home directory. And if you look at our files, let's make a file real quick, and we'll just call it new file. And if we do ls-l, I'm going to explain the ls-l command in more detail, as well as the permissions. When we create a new file, you can see here by default, the user associated with this file is user 1, and the group associated with it is user 1. And that's based off of the fact that I'm logged in as user 1, and my primary group is user 1. So if I change my primary group to doctors, then this would say doctors, and this would say doctors as well. Okay, so now we've created a user and we've created a group. Let's go ahead and talk about how we can now create the users and groups that we just created. So to delete a user, all we have to do is run the command userdel user and then the username. So if I want to delete user 2, we just do that. We need sudo, of course. And if we just go to /etc/passwd, let's see if user 2 is gone. And you can see here, user 2 is now gone. So that's how we delete a user. To delete a group, it's pretty simple as well. The command is groupdel, and you just type in the name of the group. So we can delete nurses. And we need sudo, of course. So now if we do cat /group, you can see here we have doctors and janitors, but no longer nurses. One thing I wanted to quickly point out is when you create a group, when you create a user, let's say you gave the user a certain password, but they want to reset their password or change their password. To change the password of a user, all you have to do is run the command passwd. And the argument for this command is the name of the user. So if I did passwd user1, that's going to prompt me to change the password for user1. If I leave it blank, it's going to change the password for whatever user I'm logged in as. So in this case, technically I'm logged in as user1, so this would also be user1. But I wanted to point out the differences. So passwd without an argument is going to change the password for whatever user you're logged in as, which is user1. But I can also change the password for any other user. So if I type in password Sanjeev, this is going to change the password for Sanjeev. So let's go ahead and do that. I'm going to change it for user1, and it's going to prompt me for the new password. Just enter that, enter that. Oops. All right, so now we've changed the password for user1. So it's pretty simple to change a password in Linux. All you have to do is just use the passwd command. Okay, so we've added users, we've added groups, we've deleted users and groups. Now let's discuss how to add a group to a specific user, or sorry, to add a user to a specific group. I haven't showed you guys that yet. So let's take user1. I'm logged in as user1, but it doesn't matter who you're logged in as. And let's say that we want to add user1 to the doctors group. So let's say we want them to be a doctor in this case. To do that, we have the command usermod -ag. Then we provide the group name, which is going to be doctors. And then we provide the username that we want to add to that group, which is user1. So this is going to add user1 to the doctors group. But I want to explain what these options are. The -a, -g. Actually, this is a typo as well. This should be a capital G. But to explain what those options do, let's take a look at the -- help option real quick. So what the -a is, it's saying it's going to append the user to the supplemental groups mentioned by the -g. So that's why we need these two options, because -a is going to tell the user that you have provided will then get added to the groups mentioned by the -g option. So that's why we need -a capital G. So let's do that. We can do usermod -ag, then the group name, doctors, and then the username. So user1. And by the way, we can string as many groups as we want. So if we wanted to add nurses and janitors, then this would say user1 is now part of doctors, nurses, and janitors. Although we deleted the nurses group, so that's not there. So let's say we want him to be a doctor and a janitor. Now, if we type in the command groups and then the name of the user, user1, that's going to show us all the groups that the user associated with. So here you can see he's obviously associated with his primary group, which is the same name as his own username. He's part of the pseudo group, and now he's part of the doctors and janitors group that we just added him to. And again, as I mentioned before, we could always go into the /etc/group file and manually add him to the doctors and janitors groups if we wanted to. Okay guys, so I showed you how to create and delete groups as well as add users to specific groups. Let's take a look at how to remove a user from a specific group. So if we take a look at user1, we can see he is part of the doctors, the pseudo, and the janitors group. And let's say I no longer want him to be part of the janitors group. To remove him from that group, we have to run the command del user, the username, and then the name of the group I want him to remove him from, janitors. And once we do that, we gotta have root, so sudo. Okay, and now if we do groups user1 to see what groups the user1 is associated with, it's only doctors and sudo. And I want to point out one thing. Remember, del user, the command we just ran, is to ensure that we remove a user from a group. This is very different from user del. User del is used to delete a user. So just keep that in mind. Both commands are pretty similar. They're just flipped. So just to reiterate, del user removes users from groups, and user del is to delete users from the system. Okay, so I think I've covered pretty much everything I wanted to cover for users and groups. Now let's move on to permissions. So permissions are the rights to act on a file or a directory, and basically we have three basic rights. We have read, we have write, and we have execute. To explain that a little further, let's take a look at a file with ls-l, which, remember, the -l is going to print it in list format, and it's also going to show us the permissions for a file. So if you take a look at any of the files here, this is all the permissions that we're concerned with. So we talked about this. This is the user associated with the file or directory, and this is the group associated with the file or directory. And here, these are the permissions. Now, I found a nice little diagram that kind of explains this. So let me pull that up. Give me a second. So look at this file, this diagram right here. Basically, when you see this part right here, remember the first, symbol is going to indicate what type of file it is. And we have a dash that implies that that's a regular file. If you don't see a dash, that means it's a special type of file. And there's a few different kinds, but the main one you'll see it with the letter D, and that indicates it's a directory. Okay, but that's not really part of the permissions. The next 9 characters are what we are really concerned with. So the 9 characters can be broken up into 3 groups of 3, and they explain what the read, write, and execute permissions are for a specific file for different users based on what category they fall into. And I feel like I don't need to explain this, but just in case we're all on the same page, when you give someone read access, that means they have the ability to open the file and look at it. When you give them write access, it means you're giving someone the ability to actually create, edit, and modify that specific file. And when you give someone the execute permission, that means that you allow them to run a script, execute a script, right? So now that we have that out of the way, let's talk about what these letters mean. So as I stated, this gets broken out into 3 groups of 3. The first 3 are going to represent the permissions for the owner of the file. The next 3 are going to represent the permissions for the group, and the last 3 are going to represent the permissions for everyone else. And each one of those entries has 3 letters, RWX. So if you have an R, that implies that whoever this is, which the first 3 spaces represent for the file owner, this is saying, when there's a letter R here, that means the owner of the file can read it. If there's a W, this implies that the owner of the file can write to it. And if there's an X, that means the owner of the file can execute it. And if we go to the next set of 3, it's the same exact concept, but instead of being for the file owner, this represents the permissions for the group owner. So here, because we have R here, that implies that the group, any users associated with the group associated with that file can now read to it. They also can write, and they can execute. And then the final 3 is for everyone else. So all others, this would be giving them read, write, and execute permissions. So let's exit out of that and go back to the command line. And let's take a look at, a couple of these files or directories. So we've got the desktop directory. And as I stated, the first line indicates what type of file it is. Because there's a D, this implies that it's a directory. And now we've got the 9 different I get permissions that I guess you want to call it. So we have the first 3, right? And this represents the permissions for the user of this directory or file. So here the user is Sanjeev. So that means that the user has read, write, and execute permissions. Now let's go to the next 3, and this represents the group associated with the file or directory. And we can see here the group that's associated with this directory is doctors. So this next 3 permissions represent the permissions for anyone in the doctors group. And what this is saying is, since there's an R, that means we can read. Anyone in the doctors group can read this directory, open it up or whatever. But then where the W would normally be, we see there's a dash. And that means they don't have that permission. So this is saying that anyone in the doctors group does not have write permission for this directory. So they can't, modify this directory. They can't make any changes. And finally, we have the execute flag. And this is, since you see an X, it means anyone in the doctors group can execute anything. And the final 3 are the permissions for everyone else. So this is saying that everyone else can read. Once again, we have a dash, so they can't write, but they can execute. All right, and just to hammer home how this works, let's just do one more example. So we see my second file. The user is Sanjeev, and the group is Sanjeev as well. And let's take a look at the permissions. So the first 3 represent the permissions for the user, which is Sanjeev. And we can see here I have read access, I have write access, but I do not have execute. So I cannot execute this if this was a script. Then the next 3 represent the group. So we have a group Sanjeev as well. So anyone who's part of the Sanjeev group would follow the permissions that are listed in this second set of 3. So here we have the R, which means we can read to it. Then we have a dash where the W would be, which means we cannot write to this file. And then we have the last one, which is execute, which means since there's a dash, it means we cannot execute this file either. And then the last 3 are for everyone else. So anyone that's not Sanjeev and anyone that's not part of the group Sanjeev, they can read the file, but they cannot write and they cannot execute the file. And just to show you, just to prove to you that that's what the case is, let's change to user 1. Let me just see what groups I'm a part of. Okay, so I'm part of doctors groups, so that doesn't matter. But let's go to cd/home/Sanjeev, and let's do ls-l. And let's take a look at this second file. So this says that anybody that is not Sanjeev and not part of the Sanjeev group can only read it, right? So this is the other section. So as user 1, I would fall into the category of others because I am not Sanjeev and I am not part of the Sanjeev group. So that means I can only read, but I cannot write and I cannot execute. So if I try to cat my second file, not a problem. It's an empty file, so you can't see anything, but just know that the command ran and it worked fine. But if I try to write to the file, so if I try to do vi my second file, you can see down here it says read only because I do not have the ability to modify this file as the permissions do not allow me to. Okay, so hopefully that explains explained how permissions work. I do want to show you how to actually modify the permissions. And this is an important part of being a Linux administrator is you'll be modifying the permissions for files all the time. So the command to modify the permissions for a file is chmod. But there's there's two different ways to actually use chmod. So let me start off with method 1, and I'll give you a few examples on how to do that. Then once we finish method 1, we'll then take a look at method 2, and I'll show you how to use that. And then based off of whichever one you feel more comfortable with, feel free to use either one. Both are valid methods and both do the same exact thing. It's just a different way of doing it. Okay. So with chmod, to run that command, you just do chmod, but then you have to provide certain arguments and certain things to actually modify the permissions. Now we have a few different options. We have U, we have G, O, and A, okay? And let me explain what each of those letters means. When you type in the letter U, this means we're going to change the permissions for the user, which means the first 3, right? When you do G, that means we're going to change the permissions for the group, which are the second set of 3. And when you do O, this stands for other, and this represents the permissions for the last 3. And A means we're going to change the permissions for all of them, for the user group and others, okay? So you pick a letter and then you use an operator, okay? And we've got several different operators. We've got the plus, we've got the minus, and we've got the equals operator. And the way that these work is when you use the plus operator, that means we're going to give it a certain permission. And when you use the minus operator, it means we're going to take away a certain permission. And when you use the equal sign, that means we're going to give it an exact permission. Okay? So let me show you how to use this command now that you understand the basics. So what we do is, let's say for my second file, we can see here the user cannot execute this file. Okay? And let's say we want the user to be able to execute that file. We have to type in U, because remember, U represents user. And we want to add the execute permission. So you would do a plus, and then you would do X for execute. And then we type in the name of the file. And we need sudo, of course. And once we do that, if we do ls minus L, notice how there's an X now here, because we've now given the user the execute permission. And if you look back here, you can see there is no execute permission, right? And see, that's pretty simple, right? You just add the execute permission for the user. Let's say we want to take away the execute permission for the user now. We would just do the same command, but this time we do the user and we do minus the execute permission. So we are taking away the execute permission, and then we give the name of the file. And once we do that, we can see here we no longer have the execute permission. And I want to give you a few more examples just to make sure you guys understand this command. Let's say we want to now change it so that the user gets the execute permission and the group, or actually let's say the user gets the execute permission, but the other category loses their read permission. So we do chmod, and remember, we want the user to gain the execute permission, and we can actually string as many of these as we want. So then if we do comma, and now we do O for others, so that means we're going to change the permissions for the last 3 other, and we want to subtract read, and then we do my second file. If we do ls minus L, you can see here we've given the user execute permissions, but we've taken away the read permission for the others. All right, so you can string as many as you want. I guess the one last operator I wanted to show you was the equal sign. So I showed you plus, I showed you minus. Equals will, actually before we do equals, let me just show you what happens when we try to add an X when there's already an X for the user, and when we try to remove an R even though we don't already have an R for others. So with the adding and subtracting operators, if we try to add something that's already there, it doesn't change anything. And if we try to remove something that isn't there, it doesn't change anything. So those only work when you're giving instructions to make a change. But if the commands ultimately don't change anything, then it won't make a difference. Okay, so if we do chmod, we need sudo, of course. And let's say for user, we want to give him execute permission. And for others, we want to give them, or we want to take away read permission, right? So we're giving them execute permission, even though they already have it, and we're taking away the read permission for everyone else, even though they don't have it as such. So if we do that and we just type in the name of the file, you'll see here nothing's changed because we didn't actually give it instructions to make any changes. Now let me show you the equals operator. So we do chmod, and then we do let's say for the group section, we want to take away the read permission, but we want to give them the execute permission. We can technically do group -r, and we can do group plus execute, and then my second file, right? So that'll take away the read permission for the group and add the execute permission. But we could also just do g equals, and we can just give them the exact permission we want it to have. So we just want it to have x. So that means it's not going to have read or write. If we wanted to give it full read, write, and execute permissions, we could just do rwx. If we just wanted to give it just write permission, we could just do w. If we wanted to have, write and execute, we just do wx. So the equals tells you the exact permissions you want. So if we do, originally we just wanted to have it so that it only had execute permissions, and we took away the read permissions. So if we do that, and then my second file, sudo, you can see here for the group, we only have execute permissions, and we can tweak that again. But let's say we want the group to have read and write, but no execute. Then we just type in rw, and we can see here the group has read and write, but no execute. And the last thing I wanted to cover was using a. So we have chmod a, and let's say we want everyone to have full read, write, and execute. Remember that a applies to all three. So it applies to user, groups, and others. And we can do equals, we can do the plus operator, minus operator, but let's just do equals rwx, and then my second file. So this is going to give user, group, and others full read, write, and execute. Yep, and we can verify that, and look at that. Now everyone can, read, write, modify this file. They can execute this file. So that concludes method 1. The next method is, it's pretty similar. Well, it's the same exact command, but instead of using, like the letter A, O, or U or G, and then providing the permissions, instead we actually give the chmod command a number, and that number represents the permission. So at first it'll seem a little trickier, but once you start memorizing the numbers, it becomes a lot easier, and you'll find that a lot of people end up using that a lot. Okay, so this chart I found on the internet, it goes over the different numbers, and how this works is if we break down the 3 groups, right? We have 3 different groups, which are user, group, and others. We have to provide permissions for those 3 groups. So chmod will take in 3 numbers, and those 3 numbers will represent the permissions for either user, group, or other. And if you want to take a look at this chart real quick, you can see what each number represents permissions wise. So if you give the number 0, that implies that you are taking away all their permissions. So no read, no write, no execute. If you give it a number of 1, you're just giving it execute. If you give it a number of 2, it'll have just write access. If you give it 3, it'll have write execute. 4 is read only. 5 is read and execute. 6 is read and write, and 7 is read, write, and execute. And as I stated before, we have to give 3 numbers. And so if you wanted to give everyone, the user, the group, and others full read, write, and execute permission, remember that 7 represents read, write, and execute. So you'd give 7 for user. Then you'd want the group to have all 3, so you'd give the group 7, and then you'd give others 7 as well. So the number ultimately that you would put into the command is 777. Let's say that the user should have full read, write, execute permissions, and let's say the group should only have read permission, and the others section should only receive a permission of 0. So they shouldn't be able to read, write, or execute. The 3 numbers you'd give is 7 would be the first number because that represents a user and you want read, write, and execute. The group we wanted just read only, so we would give it a 4, and then everyone else should have no permission to do anything, so they'd give 0. So the number you'd ultimately give is 740. And so that's how this command works. Instead of memorizing all 8 of these numbers, I believe there's an easy way to remember this, and the best way to do that is remember 4, what 4 is. So 4 is for read permission, and 2 is for write, and 1 is for execute. So those are the 3 numbers you actually have to remember, is 4, 2, and 1. Okay, so if you just want to give a user read permission, you give it a 4. If you want to give it write permission, give it a 2. If you want to only give it execute permission, give it 1. But from these 3 numbers, we can derive all the other numbers. So let's say we want to give a user or a group or anyone else read and write permission. So remember, read is 4 and write is 2. So if you want to give him read and write, that means you would just add those 2 numbers. So what's 4 plus 2? That's 6. And if you go down to 6, you can see that's read and write. And if you want to give him read, write, and execute, just add those 3 numbers. So read is 4, write is 2, so 4 plus 2 is 6, and then execute is 1. So 4 plus 2 plus 1 is 7. And you can see down here, 7 is read, write, execute. And if we just want write and execute, just add those 2 numbers up and we get 3, right? Because 1 plus 2 is 3. And you can see here it's write and execute. Okay, so let's go back to the command line and we'll do a few extra examples of that. So we've been messing around with the mySecond file. So right now we're giving it full permission for everyone. Let's say we want to make it so that the user gets read and write permission, no execute. Let's say that the group should receive only execute, and let's say that the everyone else should only get read permission. Kind of weird permissions, but I want to make sure you guys fully understand how to use this command. So let's do chmod. So we said that the user should get read and write permission. Okay, so let's find out what number we need to use for read and write. So remember, read is 4, write is 2. Add those 2 numbers up, that's 6. So 6 is going to be read and write permission. And just to make sure we go over that again, remember, read and write is the number 6. So chmod 6. Then the groups should have only execute permission. So execute, as I stated before, is just 1. And everyone else should have just read permission. So what's read? Remember, read is just 4. So you do 4, and then the name of the file. And let's verify the permissions changed. So we can see here, user has read write, group has execute, and everyone else has just read. So that's how we use this command with the numbers. Let's do a few more examples just to make sure you guys fully understand this. Let's say we want write and execute permission for the user. So write and execute, so that's going to be chmod, and the user is going to want write and execute. So remember how to derive that. We do 1 + 2 is 3, or just memorize what write and execute is, which is 3. Then let's say we want the group to have only, let's say we want the group to have full permission. So they read, write, and execute. Let's look at what that is. So 7 is read, write, and execute. And let's say we want everyone else to only have write permissions. So just write is 2. So 372. Then the name of the file. And remember, we need to do sudo. And when we do that, we can see here we have exactly what we want. The user can write and execute. The group can do all of them, read, write, execute, and everyone else can only write. So till now, we've mostly been changing the permissions for a file. I want to show you one specific behavior that's exclusive to directories. Okay, so let's create actually we don't need to create a directory. Let's say we have the documents folder, right? And I'm gonna go into the documents folder, and I'm gonna just make a few files. Let's just file 1. Oh, Jesus. Oh, I'm logging this. Actually, let me go to my home directory. So take a look at the permissions of the files within the documents directory. So right now, they have the user can read, write, but not execute, and the group and everyone else can only read. And if we go up a directory, let's see what the permissions are for the document directory itself. So the documents directory have a permission of read, write, execute for the user, read and execute for the group, and read and execute for everyone else. So if we do chmod, and let's say we want to give full permissions for the documents directory. So we want everyone to have read, write, and execute permissions. We can do 777, or we could technically do a equals rwx. You know, both will accomplish the same thing. So 777 and then documents. Let's take a look at the permissions and see what happens now. So now we have full read, write, and execute permissions for the directory. And if we go into the directory, there's going to be some unusual behavior. And you can see here, the files in the directory still have their old permissions. So even though we change the permission of the directory itself, it does not change the permissions of the files contained in the directory or any other directories within that directory. And this can lead to a lot of problems. Generally, when you change the permissions of a directory, you want everything else to be changed as well. Or then if a certain application or user is trying to access files in that directory, they can get into the directory, but they can't modify or change the files within that directory. So to change the behavior of the chmod command so that it recursively changes the permissions for all the contents of the directory, not just the directory itself, we should take a look at the command chmod and just take a look at --help or the man page. And there's a recursive option. So what this does is it'll change the files and directories recursively. So all the permissions will get updated to all the contents of the directory itself. So let's take a look at this again. Well, let's go up a directory. And I'm going to run the same command again, but with the -r flag. And we're going to do 777. And we're going to do the documents directory. So it already has all the permissions, but I'm just doing it again. Actually, just to show you that there's some change being made, let's just make that a 5. Okay, so when we change the last one to a 5, it means it took away our write privilege for all others. But now if we go into documents, take a look at that. The permissions match the permissions of the documents because we changed it recursively. So everything in the documents folder is going to get changed as well. All right, guys, so now we just have 2 last commands I want to show you before we wrap up this video. And that is the chown group and the change group command. So we can see here the owner of this file, file 1, is user1. But let's say we didn't want user1 to be the owner of that file. Let's say we want it to be Sanjeev. We can do that using the chown command. So if we do chown, we'll need sudo, chown, then we put the name of the new user that we want for the file, and then the file name. If we do ls-l, you can see that the user is now changed to Sanjeev. And we can also change the group of a file. And to do that, we have this command chgrp, and we do the name of the new group and the file we want to change it for. So we're changing the group for file 1 from doctors to Sanjeev. And you can see here it is now changed. All right, so let's go up a directory. And let's do the same thing for the documents folder, just to show you the behavior for the documents directory. And so let's change the owner. Okay, so now you can see the owner is now Sanjeev, and let's change the group as well to Sanjeev. And if we look at it, the ownership now is Sanjeev, and the group is Sanjeev as well. But if we go inside the documents directory, we're going to see the same exact behavior that we saw with chmod. The changes don't get propagated to the files or the contents within the directory. You can still see that user1, doctors. So if you want to change all the ownerships and the groups for a directory as well as the contents of the directory, we have to perform those commands with the -r flag so they perform it recursively. So let's go up a directory and let's do chown -r, and it's going to be Sanjeev. Even though the directory is already owned by Sanjeev, we want to make sure that all the contents within the documents directory get changed as well. And we need sudo, and if we change directories into the documents directory, you can see here the owners for all the files have recursively changed to Sanjeev, And we can do the same thing with the change group command. So chgrp -r for recursive, and then the new name for the group, and we can change it to for the documents directory, and we need sudo. So once we go inside the documents directory, if we take a look at it, you can see all the groups have changed to Sanjeev now. Okay, so that's pretty much everything I had for this video. Hopefully that helped clear up any confusion you might have had when it comes to users, groups, or permissions. This was just a quick video. Well, it didn't end up being that quick, but hopefully this video was helpful to you guys. If there's still any questions that you guys might have, let me know, and I can post up a follow video giving more examples if that would be helpful to you guys.